We are in Chapter 2, Exploring Data with Tables and Graphs, Section 2.1, Frequency Distributions for Organizing and Summarizing Data. We have a lot of definitions again in Chapter 2. And starting with this, we have frequency distribution is a table in which lists the category or classes of data and the number of occurrences for each category of data. So the big part here is that this is a table. Then we have classes, which organize our categories in certain ways, and these are defined by certain groups that we have. We have a frequency for a particular class is the number of original values that fall into the class. Lower class limit is the smallest value within the class, and the upper class limit is the largest value within the class. We have class width is the difference between consecutive lower class limits, and difference again means subtraction. Open-ended is if the first class has no lower limit or the last class has no upper class limit. Then we have a little formula here, which is calculating midpoints. And the class midpoint is the sum of the lower class limit and the upper class limit, and then dividing that by 2. The first example that we have says the number of persons under sentence of death as of December 31st, 2008 in the U.S. is listed in the table below. So you can see that there's ages listed in classes and number or frequency that we have for each of those groups or classes. So the first question that we have, it says determine the class width. And remember the class width says up above is that it's the difference between consecutive lower class limits. Consecutive just means one right after the other or two that are right next to one another. So I'm going to go ahead and use the first two classes that we have, and I'm just going to do 30 minus 20, and I get a class width of 10. The next question, part B, says, is this table open-ended? And we will say yes. And the reason why that this is open-ended is because that last class that we have says 60 and older. So that means that we don't have an upper limit there. So 60 and older. Part C says determine the lower class limit for the third class. So our third class here, the lower class limit that we have would be 40. And then D says determine the upper class limit for the second class. So looking at the second class here, that upper class limit would be 39. Is the data discrete or continuous? And so the data that we're dealing with here is ages. It's not the frequency. It's not the number that we're counting. This is a frequency distribution. But the data that we're talking about here is the ages, then how old the people are that are under the sentence of death as of December 31st, 2008. And that is continuous. And again, with ages, that is something that is continuous. Remember, we talked about you're not exactly 21. You're 21 with so many months, so many days, so many hours, so many seconds, and so on. The next thing that we have here is constructing a frequency distribution. And so this would be what you would use if you had to construct it on your own from your own data. And so the data, first thing that we would have to do is select the number of classes, and this is usually between 5 and 20. We're going to calculate the class width. And to do that, we're going to take our largest data value minus our smallest data value and divide by the number of classes that we want to have. Then we're going to round to a whole number. It's usually best to round up. 3 says to choose a value for the first lower class limit based upon the data that you have. 4 says using the first lower class limit in the class width, list the other lower class limits just by adding. And then step 5 says write all lower class limits in a vertical column and calculate all upper class limits. Use each individual data value to calculate the total frequencies for each class. So the next definition that we have is the relative frequency, which is how often something happens divided by all outcomes. And then we have relative frequency distribution, which again, that word distribution is our table. So this lists the categories of data together with the relative frequencies. There's formulas here for relative frequency for a class, which is the frequency for the class divided by the sum of all the frequencies. And then to figure out this as a percent, we would multiply it by 100%. The sum of the percentages is a relative frequency distribution must be very close to 100%. There's going to be a little bit possible that you might be off by just maybe it's 99 or 101, and this is just due to rounding errors. The next definition we have is a cumulative frequency distribution, and this is the frequency for each class is the sum of the frequencies for that class and all previous classes that we have. So the next problem that we have on here, the next example, says the data represents the weights of each 2015 men's U.S. soccer training camp member. Use the data to construct a frequency distribution, a relative frequency distribution, and a cumulative frequency distribution. So as you can see, all the weights are given here. And the first thing is I'm going to give you guys more information rather than you constructing them on your own, which everyone in the class could do differently and still be correct. It makes it very difficult to grade. So I'm going to go ahead and tell you guys that the first lower class limit that we are going to have, so our first lower class limit is going to be a weight of, and we'll say 130. And if you look at your data over here, you'll notice that there is no one under that weight that we have. And I'm going to go ahead and say, why don't we have a class width? And our class width, and again, this is just given to you guys. You can use something different, but to make sure that we all do it the same, I'm going to go ahead and say it's going to be 20 pounds. And so there's lines on here to help you organize all your data. So the first thing I'm going to do is draw a vertical line down. I'm going to zoom in here, and I'm going to go ahead and call this weights since that's the data that we are talking about. And calling this weights, we're going to go ahead and start with our first lower class limit, which is 130. And then if you look at the data that we have here, the heaviest person that we have that's on the team is 215 pounds. So I need to keep going with my classes until I hit a class that's going to include that amount. So adding on my class width, which was 20, I get 150, 170, 190, and then 210. And if I were to go with another one, I would be at 230. So I'm not sure if I need that last class. Let's go ahead and look at those upper class limits. So we're going to go from 130 to 149. And then we go to 170, so that class before that's going to end at 169. The next one will be 189. The next one's going to be 209. And the next one's going to be 229, which includes that weight of 215 pounds. So I'm going to go ahead and erase that last class that we had considered that we might need. I'm also going to ahead and write down total down here. And for total, I'm going to be adding up, just checking to make sure everything's okay. So from here, we're going to go ahead and put frequency. That's the first thing that we need to do is make a frequency distribution. I'm going to make another vertical line straight down. And I'm going to count up all the people that are between 130 and 149 pounds. So I'm just looking at my data. It's a good idea to circle, underline, something like that so you guys can keep track of which ones you've used and making sure that you've got them all. And so I'm just looking at all the numbers and I'm going to circle the ones that are between 130 and 149 pounds. So I have 3 members total. Then I'm going to do this again for the weight of 150 to 169. And when I do that, I'm going to get 8. So try to do that on your own. And then I get 11 for the next class, which is 170 to 189. And then 3, and then 1. If you were to add these up, you should have the total number of people that are in the training camp, which is 26. So that checks. So this right here is called a frequency distribution. We are also asked to come up with a relative frequency distribution. So for the next thing I'm going to do is write relative frequency. I'm going to abbreviate it just so it fits, but feel free to write out the whole word. Draw another vertical line. And remember, relative frequency was taking the frequency for each class and dividing by that total that we have, which is 26. going to go ahead and round 3 decimal places here. And so for the first one, I would take 3 and divide it by 26. Rounding 3 decimal places, we get 0.115. And then we're going to do the same thing on the next one. It's going to be 8 divided by 26. Rounding 3 decimal places, we get 0.308. And then I'm going to go ahead and do 11 divided by 26, which is 0.423. Then we're going to do 3 divided by 26, which we did up above, which is 0.115. And then the last one, which is 1 divided by 26, which is going to be 0.038. If I were to add up this total column, the relative frequencies, we should be close to 1. And if you notice, it doesn't exactly equal 1, but it is 0.999, which is relatively close. So we'll go ahead and put a check there. That is a relative frequency distribution and a frequency distribution so far. It is also asking for us to do a cumulative frequency distribution. So I'm going to go ahead and label the next column that we have over here, cumulative frequency. And cumulative frequency, we're going to be looking at our frequency column that we did first. And it says by definition, it's going to be the sum of the frequencies for that class in all previous classes. So since the first frequency that we have is just 3, let's start there. The next one is an 8. So I'm going to go ahead and add 8 plus the ones before it, which is adding 3. So we get a total of 11. The next one, I'm going to take my class frequencies, which is 11, and add up all the ones before it, which is adding up the 8 and the 3, and we get 22. Then I'm going to add up 3 plus 11 plus 8 plus 3, and we get 25. And then adding up that whole entire column that we have, we get 26, which should check to your total frequencies. So this is a cumulative frequency distribution, a relative frequency distribution, and then also a frequency distribution. The next definition we have is a normal distribution, a distribution that starts off with low frequencies and then increases to high frequencies and then decreases again. It's also approximately symmetric. We can combine 2 or more relative frequency distributions in one table and make comparing our data very easy. So the next example that we have is going to explore chocolate chip cookies, and we will look at that together in class. So the next section we have is 2.2, which is dealing with histograms. And a histogram is constructed by drawing rectangles for each class of data. The height of each rectangle is the frequency or relative frequency of the class. The width of each rectangle is the same, and the rectangles touch each other. So a lot of important stuff in here. So again, for our histograms, the rectangles will touch one another, and it's also going to have the widths should be drawn the same. One way that a variable is described is through the shape of the distribution. So on the next page, there's 4 different graphs here. We have uniform distribution, bell-shaped distribution, skewed right, and skewed left. So uniform distribution, the frequencies of each category are the same, and you can see looking at your histogram on the right that it is very straight across, they're all the same, versus a bell-shaped distribution, which is going to be the highest frequency occurs in the middle, and the frequencies tail off and get progressively smaller on the left and to the right of the middle. This is also going to get us into our normal distribution. Then we have skewed right and skewed left. Skewed right, the tail to the right of the peak is longer than the tail to the left of the peak. And skewed left, it says the tail to the left of the peak is longer. And so if you look at the peak of where those are for both of them, you'll notice that skewed right has a longer tail going to the right. And skewed left is going to have a longer tail going to the left. To determine if data comes from a population that is approximately normally distributed, a normal quantile plot can be used. The exact process is covered in section 6.5. If the data distribution is close to normal, the plotted points will lie close to the shape of a straight line. And so if you look at these, we have different histograms, And then our normal quantile plots that again we'll cover more in depth in chapter 6. But if you look at the first one, it is very normal, and you'll notice that those points are close to a straight line versus the ones over here to the right, which the points are more curved.